Hello, welcome back. In this video, we'll talk about the filtration aspect of water treatment, and we talk about the rapid sand filter working and design parameters. Now you look at this picture. This is the rapid sand filter compound. Okay, this is two different components of rapid sand filter. The first one is the filter box, and what you say is nothing but the filter bed. So this is your filter bed. Filter bed is nothing but the sand material, filter sand. And second one is the gravel support. And the gravel support is the layer which is below that particular sand. And sand is having effective size of 0.4 to 0.6 mm effective size, detent size. And then this filled gravel will be around 10 to 15 centimeter thickness, usually 4 to 5 layers. So that makes it to be around 40 to 45 to 50, 40 to 50 centimeters or even 60 centimeters thickness. Finer size is at the top and coarser at the bottom, and different sizes are also available now. Under drains is nothing but the filtered water is passing through the filter bed and enters into the slotted pipes at the bottom. So what will happen is this filter water passes through the sand and passes through this and enters here. And these are the pipes. This is called laterals. These pipes are called laterals. They are spread out across the width of the entire filter bed. And this is called the main pipe or manifold pipe, connected through the entire length of this filter. And these laterals, they are having slots, and water will pass through these slots in the lateral pipes and pass through these laterals and collected at the central pipe, manifold pipe. And this is given a longitudinal slope towards one direction, and all the water collected from the different parts of the filter bed through the laterals are now passed through the central pipe and passing through the central pipe towards one direction of this gravity, this bottom slope, and then they will be collected as outlet. Then we are having wastewater troughs. Wastewater troughs means you can see here small pipes. They are open pipes, open pipes here. Top is open. So they are used to collect the wastewater from the filter during cleaning operations. During the cleaning operation, they are used, right? We will discuss only at the time of design part. Inlet and outlet arrangement. The outlet is nothing but the water collected to the manifold. Now you can see some spacing is there. Spacing is there in the wall and this particular small portion. So whatever the inlet water will be entering into the small chamber. This is called inlet chamber. So water will be overflowing this weir and passes through the filter bed from top to the bottom. And clear water tank is nothing but the treated water is collected. And air compressor and wash water storage tank, they are used only during the cleaning purpose of the filter. So now you see here in the operation part, if you see, this is a typical section of the filter with all the different walls. Now, as I told you, this is the inlet chamber. So now he's having a wall here, wall number 1. The raw water will be coming through this wall. By opening this wall, water will enter through inlet chamber. Now you can see here, this is the weir, and water will be overflowing this weir into the bed. So this is the top layer of the water level So normally we represent with a small triangle here. So that is the water level there. So now what you are going to see is water is now filtered through the sand bed, through the sand, through the gravel at the bottom, the under drain pipes. Now you can see here, this is the manifold, and where it is coming here, this is coming to filtered water tank. So this is clear water tank. So clear water tank, I'm writing CWT. So I'm putting CWT here. This is nothing but clear water tank. So what is having here? You're having a valve 2. So if you control valve 2, the clear water directly goes into clear water tank after filtration. If you control valve 1, raw water will enter into the filter bed. So now after some time, what will happen? The particles, whatever are there, they get clogging the voids between the sands. So the void should be cleared so that then only the water get filtered. What you are going to do? So we are having two utilities here. What are the utilities? This is the air compressor and this is the wash water tank. The air compressor is connected with wall number, this is 6. If you open this wall, the compressed air will come and enter into the filter bed from the bottom. So if you open this, then this air will pass through the gravel and into the sand. So when you're sending air, then ultimately what will happen is the closely packed particles of sand, they'll get opened up. They'll get opened up like this. So ultimately what will happen is whatever the dirty particles which are attached here and clogging this water movement downwards, they'll go down to the bottom. And where they will go? They will go to the bottom of the filter bed. So now we have to remove them up. What we are doing is we are operating this wash water. This wash water is coming with high pressure, high velocity. So you are operating this particular wall number 4. So then wash water will come from the bottom and you try to push all this water up. This entire water is now coming from the bottom of the filter, going to the top. So ultimately what will happen? What are the dirty particles which are coming down? They are pushed by this wash water. And where they will go? So some particles, they will go again into the inlet chamber and they will be moving through this particular portion and they are collected in the what you call as wash water drain. To this, what we have to do? We have to open wall number 3. Now, what will happen? Some heavy particles are also there. So this wash water may not go to that far distance and then they will be collected into this wash water trough. Is nothing but a small collection channel. So usually we are having a wash water channels as a rectangular or sometimes you can go with a triangular channels. They're spread out across the entire length of the channel. So across the entire width of the channel or the filter bed rather. So now what will happen? So some dirty water is still there. Some dirty water is now separated out. Some dirty water is now stored in the wash water trough. It should be removed. How you are going to do that? Now what we'll do is this purpose is solved. Wash water and air compressor, we close these two walls. And now this wall number 2 is also closed. Wall number 1 is also closed earlier for the backwash operations. Now what is required here? So now we are opening the wall number 1. Wall number 1. So ultimately what will happen? The fresh water will once again come and then push this dirty water from the trough into the filter bed. And where this dirty water from the wash water trough will go, you see here where it is going, where it is going, and then coming through this particular wall and into this wash water drain. So which valve is open now? Valve number 5. Still some water is there, dirty water. That will also be coming out through valve number 3 and everything is collected here. So valve number 3 and valve number 5, they are used to collect dirty water into this wash water drain. And valve number 2 is used to collect the filtered water, clear water. Valve number 1 is used to collect the raw water. Only this 4 and 6, they are used to use during the backwash. Now all the dirty water is removed from the entire filter bed. So now the filter is ready to start working, right? So then close all the valves except valve number 1, except valve number 1 and valve number 2 once again. Valve number 2 once again. What will happen? Valve number 1 is nothing but raw water entering, and valve number 2 is nothing but clear water coming down to the clear water tank. So cleaning operation is something, normal operation is something, and recycle normal operation after backwash is something. So these are 3 stages. Usually the filters will be cleaned once in every 24 hours or 48 hours. But normal practice is they will be cleaned every 24 hours. The entire cleaning operations takes place around 30 minutes. And whatever the raw water is used here for the backwashing, that is also considered as the including the treated water. So what are the backwash water is used here is nothing but the treated water. Otherwise impurities will get added up. So backwash water quantity also should be added for the raw water for treatment. So now you see design parameters. What are the design parameters we should talk about? First is sizing of the filter bed. So in the sizing of the filter bed, first one is the filtration rate. This we have seen per unit area, surface area, 3000 to 6000 liter per hour of water is used. Surface area of the tank, it should not be more than 50 meters square for easy operation of the filter bed. The overall depth of the tank should not exceed 3.5 meter and minimum is 2.5 meters. And L by B ratio is at 1.25 to 1.35. Filter sand, effective size, D10 is around 0.6 to 0.4 meters, 0.4 to 0.6 millimeters. And depth of the sand usually 0.6 to 0.9 meters. Depth of the gravel up to 60 centimeters, 4 to 5 layers I'm talking about. And size of the under drains, there's some calculation. Using that calculation, if you look at it will be around 45 to 60 centimeters in a normal practice. And wash water troughs, which are, as it mentioned, mainly used to collect the wash water during backwashing operations. So we are having a formula to calculate the discharge. Q is equal to 1.376 B into Y to the power of 1.5. So if that means if you're having a wash water drain, so this is the wash water depth. So this is your Y. Y stands for water depth and B stands for the width of this and Q stands for the water discharge through one particular unit of wash water trough, right? So it should be in meter cube per second and B and Y are in meters. Usually they are spaced depending upon the number of wash water troughs. So usually we keep around 1.5 to 2 meter spacings and freeboard beyond this. So this is the freeboard we are keeping here. That will be around 6 to 8 centimeters or less than 10 centimeters. The wash water discharge, how much you are going to use. So you can see here for rapid sand filter, the filtered water of 2 to 5% we can consume it per wash water discharge for back washings. So then, this is equivalent to the quantity of water is equivalent to here 0.6 meter per minute per meter square. 0.6 meter per minute per meter square of volume water you are going to use. And estimation of gravel size gradation. So what is the gravel size you are going to put? We are having a formula. LG is the size or length of the gravel bed, which is equal to 2.54 K into log D. K is a constant having a value between 10 to 14. Usually we adopt the in-between value of 12. And D is the size of the gravel. We have to keep it in terms of mm. Then sand depth also we can calculate based on some empirical formula. Q d cube H divided by L is equal to BI into 29323. So BI is nothing but a breakthrough index. It depends on the amount of clogging, expected clogging. So we are having an empirical value of 4 into 10 to the power of minus 4 to 16 10 to the power of minus 3. And then Q is the filtration rate in meter cube per day per meter square. D is the size of sand particle in mm. And H is the nominal head loss. And L is the depth of sand bed. So once we calculate the filtration rate and what is the size of the particle we adopted, and if we assume the nominal head loss, then we can calculate sand depth L by assuming the expected breakthrough index. Okay, so this is all about the design parameters.